All right, today we're going to talk about the hidden chemistry that's literally all around us, and yeah, even inside us. We're digging into acids, bases, and salts. These are the fundamental players behind countless reactions that happen every single day, from the food on your plate to the soap you wash your hands with.
So let's start with something you've probably felt before: heartburn. You know that awful burning feeling? Well, that's not just a feeling. It's a full-on chemical event. It means your stomach is just producing way too much acid. So, how do you solve a chemical problem? You guessed it, with a chemical solution.
And that solution has a name. It's a neutralization reaction. It sounds kind of fancy, but the idea is actually super simple, and honestly, pretty elegant. When an acid and a base get together, they basically just cancel each other out. And what are you left with? Salt and water. That little antacid tablet you might take, that's just a base, and it's designed to do this exact reaction right inside your stomach.
Now, to really get what's happening in that neutralization, we've got to properly meet the main characters in this little chemical drama. So, let's break down what really makes an acid and a base a base. You know, you can actually use your senses to tell them apart. Very carefully, of course. Acids, like the citric acid in a lemon, have that classic sour taste. Bases, on the other hand, like soap, often feel kind of slippery or soapy. But the real classic test involves something called litmus paper. Think of it like a chemical detective. It turns red when it detects an acid, and it turns blue for a base. Simple as that. So, identifying them is one thing, but seeing what they can do, that's where things get really exciting. Because acids and bases don't just sit there. They react. And believe me, sometimes those reactions can be pretty dramatic.
Take this reaction, for example. When you mix a strong acid with certain metals, like zinc, the acid actually starts to dissolve the metal. And as it does, it releases a gas that's super flammable. But how can we be absolutely sure which gas it is?
Well, there's a really neat classic test to figure it out. First, you capture the gas coming off the reaction by bubbling it through soapy water. This creates these perfect little bubbles filled with our mystery gas. And then, you introduce a flame.
So you've got this setup, the bubbles are forming, and now you bring a burning candle or a splint right up to them, and you get a very clear result. Pop. That distinct little sound, that tiny explosion, that is the unmistakable signature of hydrogen gas. It's the definitive test confirming that the acid and metal created pure hydrogen. Pretty cool, right? But that's not all acids do. They also have a fun reaction with another group of things called carbonates. Think baking soda. When an acid hits a carbonate, you get all that fizzing. That's the release of carbon dioxide, which, by the way, is the exact same gas that puts the bubbles in your soda. Now, all these reactions are fascinating, but let's circle back to the main event. The ultimate chemical showdown is when an acid and a base finally meet. Their effects are nullified, they neutralize each other, but why does this happen? What's going on down at the molecular level? Okay, so we know what they do, but we're still missing the why. What actually gives an acid its acidity and a base its basicity? Well, the secret is hiding in something you can't even see. It all comes down to these tiny things called ions. When you dissolve an acid in water, it releases positively charged hydrogen ions, or H+. Bases, on the other hand, release negatively charged hydroxide ions, OH-. These tiny charged particles are the true source of all their chemical power. It's even what allows their solutions to conduct electricity. So how do we measure the concentration of these powerful little ions? We use the pH scale. It's a scale that runs from 0 to 14, and it tells us exactly how acidic or basic a solution is. But here's the crucial detail. The pH scale is logarithmic. What that means is a change of just one number, say from a pH of 6 down to 5, represents a 10-fold increase in acidity. This is a scale of exponential power. And this isn't just some abstract lab concept. It's everywhere. The acid in your stomach is incredibly acidic, down around a pH of 1. At the other end of the scale, you have things like household bleach, which is highly basic, up around pH 13. And sitting right in the middle, perfectly neutral at a pH of 7, is pure water. Okay, so we can measure pH. Big deal, right? Well, yeah, it's a huge deal, because these seemingly small numbers have massive consequences for our health, our bodies, and our entire environment. For instance, when the pH of regular rainwater drops below 5.6, we call it acid rain, and that small shift is enough to change the entire chemistry of lakes and rivers, making it incredibly difficult for fish and other aquatic life to survive. it gets even more personal. Inside your mouth, when bacteria break down sugars, they produce acid. If the pH in your mouth drops below 5.5, that actually starts to corrode your tooth enamel, which is the hardest substance in your body. That's literally the beginning of a cavity. And here's one last perfect, real-world example of neutralization. A bee sting hurts because it injects acid into your skin. So what's a great home remedy? Applying a mild base, like a baking soda paste. The base neutralizes the acid, and that provides relief. It's basically chemistry as first aid. So, we've talked a lot about acids and bases. But what about the third part of our title? Salts. We usually think of salt as just the neutral stuff that's left over after a reaction. But it turns out it's so much more than that.
This means we kind of have to flip our thinking. That common table salt in your kitchen, sodium chloride, it isn't always the end product. In the industrial world, it's often the critical starting point for creating a whole range of other powerful chemicals.
And this happens through something called the chloroalkali process. All it means is that we pass electricity through a solution of salt water, brine, and it breaks it down and transforms it. The chloro part refers to the chlorine gas that gets produced, and alkali refers to the sodium hydroxide, a strong base that's also created.
And what do we do with those products? We make, well, almost everything. The chlorine and sodium hydroxide that come from simple salt become the essential building blocks for soaps, bleach, PVC plastics, chemicals for water treatment, and even fertilizers. It is an absolute cornerstone of modern industry.
So, let's end on that thought. We started this journey with the simple chemistry of heartburn and ended up with the industrial powerhouse that's hiding in your salt shaker. It really makes you wonder, doesn't it? If an everyday substance like salt has this much hidden potential, what other chemical superpowers are just waiting to be discovered all around us?